I'll open that this thing also.
After normalization, stress.
Okay.
Normally, after
So right now, is it on? It's live. Okay. Uh, Good morning, guys. Welcome to our class of metrology. And so before we talk about metrology, this, as a subject, I would like to ask you guys that what do you think? What is metrology all about? Anyone? Study of atmosphere. Some people say study of weather, which I don't like. You know why? Because study of weather मतलब यार सिर्फ जो मौसम जैसा है, like what kind of weather it is it a good weather or a bad weather? We're just talking about that, but it's actually more than that. It's just not about weather. It's more than that. That is, for example, when I'm talking about for example, suppose when I'm talking about the type of optical phenomena, यार वो देखे कभी कभी मून या सन के आसपास we find a ring. Is that a part of weather? No. It's a part of atmosphere. What kind of refraction or a diffraction is happening by a sunlight or a moonlight? ठीक है? या फिर when I'm saying कि यार आज density बड़ी कम है. Yeah, the pressure is really high today, we will get a good aircraft performance, things like that. So it's not only about a good weather, it's not only about bad weather, but it's actually more than that. Now my second question is that why do we need to study metrology? Okay, anyone? Shubhamoy, why do we need to study metrology? Things like that. So it's not. हाँ जी बताइए. Good weather. It's not only about bad weather. Okay, what? To fly the yeah, jab, we know what do you say, when we're gonna be flying, we need to know that what kind of possible weather we are gonna be facing. If I know that this particular cloud is only found in this particular altitude and it is gonna give me turbulence, I will of course try to avoid it, na. But ये मुझे तो अब कब पता चलेगा? When will I actually got to know about it? Or when I will actually know about this? When I study metrology. So metrology may now when we're going to start, we're going to start with atmosphere and especially atmosphere, temperature, pressure, density, humidity. There's 5 topics and one more, that is stability. These 6 topics in metrology are very important as they are the base. अगर आपको ये चीजें पता है तो आगे जो हम when we will talk about clouds, when we will talk about winds, fronts, all of this become very easy. You know, that understanding of all these things, that you know what I'm saying, winds, clouds, thunderstorm, in सब के बारे में जब बात करेंगे, it will only get cleared if you know the 6 topics very nicely. So this is a base. If you are clear with your base, perfect. You will understand what is a cloud. When I'm talking about certain type of formation, when I'm talking about certain type of weather condition, it will get easier and easier for you. Okay. So the first topic, first chapter which we're going to start is. Okay. So we're going to start with atmosphere. So what is atmosphere? Siddharth, what is atmosphere? Layers तो बाद में आती है, उसके पहले क्या आता है? What is atmosphere? Okay. Perfect, Pratik. So atmosphere is like composition of air, composition of different gases around us. Okay, अब ये कौन सी gases हैं? What are the type of gases we are having? So the gases we have are 78% of nitrogen. अरे वही जो लेस के पैकेट में ज्यादा भर के देते हैं, वही है ना. चिप्स इतने से होते हैं 4 दाने, और जो हवा होती है nitrogen. Next is oxygen of approximately 21%. Then we have carbon dioxide of 0.03% and argon of approximately less than 1%. Normally it's 0.93% and some other gases less than that. So this is the composition and you can just start writing with your itself. पूरा chart नहीं बनाना है. Bus argon is this much, oxygen is this much. Go with that. All right. Argon of approximately less than 1%. Normally it's 0.93% and all right, so shall we go ahead? Okay. All right, so now before we go ahead with the chapter, there are certain things, certain facts related to atmosphere. So the first fact is that, because the highest amount of, the highest percentages of two gases are there. One is nitrogen और फिर उससे थोड़ा कम है oxygen. So there was a ratio percentage comparison which was done and as per weight. The percentage composition by weight of nitrogen compared to oxygen is 3:1. That means 3 is your nitrogen and 1 is your oxygen. Okay. In exams, normally, whenever you're giving a competitive exam, they tend to ask you not exactly like nitrogen to oxygen, what do you say, ratio, but they might say oxygen to ratio, nitrogen ratio. So that will be 1:3. So please ध्यान रखना whenever you're giving exam. Normally what they do, क्योंकि याद रखना है, आपने ये क्या याद रखा है? Weight is nitrogen to oxygen is 3:1. है ना? तो वहां पे ऑप्शन में you will see 3:1 and you will get so excited, but उन्होंने oxygen to nitrogen पूछा होगा और आप किया ना दोनों? नहीं इस बार नहीं। अच्छा ठीक है, क्वेश्चन ही नहीं आया। And by volume, it is nitrogen compared to is 4:1. So 4 is for nitrogen molecules and 1 is for oxygen molecules. Acha. Lot of my students normally forget 3:1 was for what do you say, weight ki ya for volume. क्या करूं तुषार, मैंने ये भी सान्या जी ट्रिक बनाई है आपके लिए। W में 3 डंडियां होती है, वेट 3:1. आई नो इट्स अ वेरी मतलब क्या ही बोलूं यार, ट्रिक है तो है ना सान्या? गुड वन. ऑलराइट, सो देन वी हैव एंड एयर इज नेवर कंप्लीटली ड्राई यार, उसमें कुछ अमाउंट ऑफ वाटर वेपर इज ऑलवेज देयर, ऑलवेज. मैक्सिमम इज 4%. ठीक है. इफ द एयर हैज लेस देन 4% ऑफ वाटर वेपर, यू कॉल इट एज अनसैचुरेटेड और ड्राई एयर. You call it as unsaturated or dry air. मतलब कब शॉयन, जब 3-4% से वाटर वेपर कम है एटमॉस्फेयर में. Now, if the atmosphere has nearby 4% or 4% of water vapor in it, moisture, water vapor, not water droplets, I'm talking about vapor, wo bhap, steam. Okay, so that if the water vapor is less, is exactly 4%, you call the air to be moist air or unsaturated air. Saturated air or moist air, sorry. So water vapor is always present, varying amounts up to a maximum of 4%, and water vapor behaves like a gas, so iska matlab सौम्या एक हाथ में moist air, एक हाथ में dry air. Comparatively, which will be heavier? Moist air. अपना आंसर पीछे नोटबुक पे लिख के साइन कर लेना. जब हम डेंसिटी वाला चैप्टर पढ़ेंगे उस दिन I'll get a तराजू, okay, the weighing scale, and I will weigh it in front of you. ठीक है ना सिद्धार्थ? वे करके फिर दिखते हैं कि moist air और dry air के बीच में which is heavier. All right, ठीक है. और यार जिसने moist सोचा है ना, ईमानदारी से किताब में लिख लो, क्योंकि कल को ये बोलना हमने तो dry बोला था. No one will do that. All right. Okay. So the points, guys, you can write. And last I will just dictate for unsaturated and saturated air. All right. So we are going to talk about the layers of the atmosphere now. Before we talk about the layers of atmosphere, start writing unsaturated air / dry air. Written, guys? Okay. So the air in which water vapor is present less than 4%. Water vapor present in the air is less than 4%. Is termed as unsaturated air or dry air. Unsaturated air or dry air. All right. Next is saturated air. Next point is saturated air. Saturated air is the air in which, start writing, the air in which water vapor present in the air is up to 4%. Up to 4% is called as saturated or moist air. Saturated or moist air. Okay? All right. So now let's talk about the layers of atmosphere. So Earth, the Earth के एकदम ऊपर, the first layer is called as your troposphere. Then it is extending till a certain altitude or height, which we are going to talk now. Then after that, we have a boundary between two layers. That is your perfect tropopause. Then we have above that another layer, which is your stratosphere. Above stratosphere, we again have a boundary which is called a stratopause. Then we have a mesosphere, then we have mesopause, then we have thermosphere, then exosphere, which is actually, getting depleted in the outer layer, like outer space. Okay. Now, the very important layers which we're gonna be focusing on in this chapter is still mesosphere. Yeah. Troposphere is very important. Why? Because most of all the weather conditions are actually happening in this layer. Now, साक्षी, अगर एटमॉस्फेयर में मतलब वेदर यहीं पे सबसे ज्यादा बन रहा है, तो can I say the 3/4 part of the atmosphere is actually in this layer itself? यार एक तो ग्रेविटी, air molecules are actually, you know, what do you say? Why we say ki density, the air molecules are near to the, you know, surface of the earth. Comparatively, as we go up, the density of the air molecules decreases. Like, you know, the amount of air molecules you have tends to decrease because air molecules have some kind of mass. And anything which has mass, it will tend to drop down near to the earth because of the gravitational force. Correct. So most of the, what do you say, density is at the lower altitude. So pressure ka kam hona, like, you know, decrease of pressure or increase of pressure is also happening in this layer. And the very important factor for creation of any kind of weather is actually water vapor. Or water vapor content is mostly present in this layer. वाटर वेपर चाहिए बादल को बनने के लिए, बादल बनेंगे तो वेदर खराब होगा. Correct. So that is why water vapor is a very important factor which you will only get most of it in this layer. And hence, और यार weather खराब ही होता है ना ज़्यादातर. हम क्या बोलते हैं यार weather बड़ा अच्छा है normally, but comparatively, but whenever we say कि अब आज weather बहुत खराब है, bad weather. So bad weather is actually because of instability. Unstable hai. This layer is very unstable. You will have all the type of weather creations, you know, ek weather kharab ho gaya, theek hona, everything is happening in this layer, troposphere. Every layer, especially when I'm talking about troposphere, stratosphere, mesosphere, has certain facts to learn. Points, eh? I will, you know, whatever we are talking about, whichever fact we're talking about, it has a proof. So let's talk about troposphere. So troposphere starts from the surface of the earth till 8 kilometers at poles, till 16 kilometers at equator. So there's no uniformity. Ki troposphere throughout the earth equal height pe nahi bhai. वो at equator, like at equator, the height of the troposphere is 16 kilometers. 16 kilometer ke stretch tak hai. Actually now as per the new ICJ book, it's 18 kilometers something. And 16.5 is for India ke upar jo aapke Tropopause hai. Troposphere over India is approximately 16.5 kilometers. At poles, the you know, what do you say, your Tropopause is troposphere is still stretched up to height of 8 kilometers. Okay, so troposphere. Okay. Now this layer, this is what I'm talking about. So at equator, it is approximately 18 kilometers. And approximately at 45° north, it is supposed to, it is actually said that it is 11 kilometers average. And over India, it is approximately 16 to 16.5 kilometers. All right. Suppose if this is my India, so yahan pe it's approximately 16.5 kilometers. Okay. All right. So now it consists of approximately 3/4 of the total atmosphere in weight. That molecules, air molecules have mass. So of course, yaar niche aayenge na gravitational pull ki wajah se. So most of it is actually present. Most of the molecules are actually present in troposphere. Okay. Then one very important point to talk about before we go ahead into this direction of layers, I would talk about one is your first is your normal layer. Second is your isothermal layer. Third is your inversion layer. Okay. First is normal layer. Now what is normal layer? As the altitude is increasing, temperature is decreasing. As the altitude is increasing, main sea level pe the, so you went 1,000 feet up, then you went 2,000 feet up, then you went, you know, up. So as the altitude is increasing, my temperature is decreasing. That is called as a normal layer. Or in ISA, that is your International Standard Atmosphere, which I will be talking about कि क्या कैसे आया ये ISA वाला thing. उसके पहले अब what I'm saying कि जैसे जैसे altitude is increasing, the temperature is decreasing. At what rate? At what rate? 2 degrees Celsius per 1000 feet के rate पे the temperature is decreasing. That means, Advait, if I'm saying that at mean sea level my temperature was 15 degrees Celsius at mean sea level, मैं 1000 feet ऊपर गई, my temperature would have dropped to 13 degrees Celsius. Then I would have gone to 2000 feet, the temperature would drop to, Shoyan? Huh? Perfect, 11 degrees Celsius. So this is called as lapsary. Normal layer mein temperature, altitude will increase, temperature will decrease. Then comes isothermal layer. Yeah, is layer mein na, even if the temperature, even if your altitude is increasing, temperature ceases to fall. What do you mean by ceases? Stops to fall. So suppose 11 kilometer pe jaakar, that is 36,090 feet approx, उस पे जाके टेम्परेचर कुछ अप्रोक्सीमेटली ऐसे 2 डिग्री सेल्सियस के रेट पे जब गए, सो टेम्परेचर ड्रॉप टू -56.5 डिग्री सेल्सियस समथिंग. ठीक है, मतलब व्हाट आई एम ट्राइंग टू से इज दैट अगर ये मेरा 36,000 फीट है और यहाँ टेम्परेचर -56.5 डिग्री सेल्सियस हो गया है और अब मैं 1000 फीट और ऊपर जा रही हूँ, that is approximately 37,000 feet. Suppose the temperature should have dropped 2 degrees Celsius more. It is actually still remaining -56.5. I went 38,000 also, -56.5. I went 39,000 feet, -56.5. So this is a layer in which as the altitude is increasing, the temperature stops to fall. It's not falling. It's stopping there. It's not falling for a certain amount. And that is from 11 to 20 kilometers. ठीक है? फिर आता है यार अपना inversion layer. इसमें the temperature is not falling. The temperature is not staying like that, stop bhi nahi ho raha hai. The temperature starts to increase with increase in altitude. The temperature starts to increase with increase in altitude. Achha, there's a reason also why this is happening. Anyone knows about it? Yes, Pratik.
Ozone के ऊपर.
So ozone layer में O2 के molecules होते हैं, oxygen के molecules होते हैं ना. What happens is that यार सन आता है, सोलर रेडिएशन पड़ती है ऑक्सीजन के मॉलिक्यूल्स पे और वो एज अ O3 आयंस क्रिएट हो जाते हैं. O3 आयंस वही आयनाइजेशन वाली आयनोस्फीयर वाली लेयर. So when this O2 molecules are converting into O3 molecules, it is a chemical reaction, and this chemical reaction is an exothermic reaction. Anyone? जिसकी अभी 12th हुई है, एंडोथर्मिक एक्सोथर्मिक क्या याद करा? हाँ अनिरुद्ध, what is exothermic reaction?
When heat is released.
When this is a chemical reaction in which the heat will be released out. So that releasing of this heat will be termed as your exothermic reaction. अब heat बाहर निकली in the atmosphere. So that particular layer or that particular amount of altitude where you're having a good concentration of the ozone layer will actually have increased temperature. So as the altitude is increasing, the temperature is also increasing. This is the reason. All right. So आप लोग सबसे पहले लिखो normal layer. Normal layer. It is the altitude. Normal layer is the layer in which Normal layer is the layer in which, as the altitude increases, the temperature starts to decrease. As the altitude increases, the temperature starts to decrease. Okay. Next is also, please underline कर लेना normal layer पे. ठीक है, तो normal layer पे क्या हो रहा है भाई? Altitude increase, temperature decrease. Okay. Now isothermal layer is the layer in which, as the altitude increases, the temperature ceases to fall. The temperature ceases to fall. So altitude is increasing in this one, but temperature is remaining constant. All right. Third is inversion layer. Inversion layer is the altitude in which, it is the layer in which, as the altitude increases, inversion layer, it is the layer in which, as the altitude increases, the temperature increases. The temperature also increases. ठीक है? All right. Okay. So now let's come on to the troposphere chart again. So troposphere में troposphere जो atmosphere की the layer, first layer, troposphere. Shri Hari, in this, like when we were talking about troposphere, what did I say? The temperature, as the altitude is increasing, temperature is decreasing. So in troposphere, which layer is there? Which layer is present? Normal layer. ठीक है? All right. Okay, so the layer of the Earth's atmosphere where temperature decreases with an increase in height. This is what? This is actually your. Which layer? Hanji. This is your normal layer. Normal layer. At what rate is called as your lapse rate? Normally it is 2 degrees Celsius per 1,000 feet. Why 2 degrees Celsius per 1,000 feet? I'll tell you about it. Why? Okay, consists of 3/4 of the total atmosphere in weight, contains almost all the weather. अरे यार water vapor इसी में present है ना? The whole water vapor moisture content is mostly in this layer. So जहाँ moisture होगा वहाँ पे cloud formation will be there. What is happening? Water vapor goes up and up and up. There will be a certain altitude जहाँ पे what is water vapor? It is warm, right? It is steam, correct? जो अपने चाय के पतीले में अगर अपन पानी को उबालते हैं तो वो जो भाप निकलती है वही water vapor है. That is steam, gas. So now this gas is going up and why it is going up and up? Because it is lighter compared to the air surrounding it. It goes up, up, up. Now, after a certain altitude, it sees that the surrounding atmosphere is colder. It condenses. And this condensation of this water vapor into water droplets creates clouds. Creates clouds. But वो ऐसे नहीं बनेगी. वो ये कहती है मेरे आसपास का जो atmosphere है ना, जब तक वो ठंडा नहीं होएगा, वहाँ condense नहीं होंगी. It needs, for condensation of water vapor, there the temperature has to be low. अब low temperature कहाँ मिलेगा शोयन? ऊपर की नीचे? ऊपर मिलेगा ना, तो वो वहाँ पे जाके condense हो जाती है. The moment it condenses, this water vapor condenses into water droplet and the formation of clouds occur. ठीक है, तो अब यार ये ना ये ट्रोपोस्फियर के अंदर ही हो रहा है जो भी हो रहा है, तो बादल कहाँ बनेंगे? ट्रोपोस्फियर में ही बनेंगे. तो वेदर क्रिएशन कहाँ होगा? ट्रोपोस्फियर में ही होगा. गॉट द पॉइंट है ना? तो जब हवा ऊपर जाती है, जब you know this air when it is going up, it is carrying water vapor molecules also with it. एंड ये स्कूल में हमने पढ़ा है कि इवेपोरेशन होता है, फिर बादल बनते हैं, फिर बारिश होती है, फिर प्रेसिपिटेशन होता है, फिर से वो पानी नीचे आता है, फिर वो पूरा साइकिल वापस से शुरू होता है. That's it. Alright. तो आप लोग ये बनाओ and it extends up to 8 kilometers at poles and ये 16 की जगह as per the new this thing it's actually 18 kilometers. Okay. 18 kilometers.
16 to 18 लिखा है.
16 to 18 लिखा हुआ है. And what about India?
India 16.9.
16.5. तो 16 to 18 kilometers ही कर लो यार. 16 to 18 kilometers.
हम goals का भी mention है 8 to 10 kilometers.
8 to 10 kilometers. ठीक है. अब जैसे जैसे टेम्परेचर वेरिएशन होता है ना, जो वो बाउंड्री है वो ऊपर नीचे होती रहती है. तो एवरेज जो वो ऊपर नीचे जितनी होती है दैट इज दिस. ठीक है. All right. Shall we go ahead? Okay. If possible, please draw it also. ये याद रहेगा फिर, या फिर मैं अलग से बनवा देती हूँ. Okay. Temperature. All right, everyone written? Done. All right. So tropopause. Okay. So tropopause क्या है? या वो boundary or line between troposphere and stratosphere. Please don't get confused that it is also a layer. No, it's not a layer. It's just a thin boundary between two layers. Up this tropopause, this for example, this is my tropopause, okay, and this is my surface of the earth. This is my tropopause. So tropopause ऊपर नीचे होती रहती है, जिससे troposphere का जो height है वो भी differ होता रहता है. So tropopause doesn't stay uniform throughout the atmosphere. It is changing. Its height is actually changing. Maybe ज़्यादा ऊपर, maybe ज़्यादा नीचे. Reason क्या है? We will talk about it. But क्योंकि अब ये ऊपर नीचे जाएगी, तो automatically जो troposphere का height है, वो भी differ होगा. अब जैसे ऊपर हो गई, तो यार troposphere automatically कैसा हो गया? ज़्यादा. The height of the troposphere has increased. अब tropopause नीचे आ गई, तो troposphere की height कैसी हो गई? कम. So the tropopause का height marks the height of troposphere automatically. Okay, and tropopause का height changes with certain facts. That is latitude. अगर poles पे है कितना है भाई? Poles पे 8 to 10 kilometers. At equator 16 to 18 kilometers. Okay. Season of the year, winter mein tropopause will be at a lower altitude. Sorry, lower height. Temperature prevailing on the day. अब भाई temperature थोड़ा कम है. Temperature is low, so it will be at a lower altitude. If temperature of the day around 2 o'clock during the day, temperature highest होता है. Tropopause ऊपर होगी. Okay, time of the day, that is what I'm talking about. During the day at 2 o'clock approx, the height of the tropopause will be at a little high, and during night या early mornings जब temperature सबसे कम होता है, throughout the day the temperature is lowest early mornings before sunset sunrise time. ठीक है, तो उस time पे it will be low at a lower altitude. Average height of tropopause is approximately 36,000, that is at 11 kilometers. The average height 45 degree north mein you will get at 11 kilometers. All right, so yeah, after reading all these facts I feel like tropopause the tropopause ki height is low at a colder temperature. Can you see latitude जैसे से ऊपर जाते हैं या latitude जैसे से बढ़ता है temperature कैसा होता है, low. Tropopause low. Seasonal winters में cold temperature is less, again tropopause is low. टेम्परेचर प्रिवेलिंग ऑन दैट डे, अगेन भाई पूरे दिन में जैसा टेम्परेचर होगा, आप कंपैरेटिवली अगर कम है तो भाई लो होगी. टाइम ऑफ द डे पे ड्यूरिंग अराउंड 2 o'clock in the mid noon, like you know, and in the afternoon it will be at a higher altitude, जबकि तब गर्मी ज्यादा होती है, टेम्परेचर इज हाई, बट at you know at early morning the temperature is low, तो उस टाइम पे भाई वो भी नीचे आ जाती है. तो ट्रोपोपॉज को ठंड बहुत पसंद है, जैसे जैसे ठंड ज्यादा होती है नीचे आ जाती है, जैसी गर्मी ओहो चलो ऊपर. Correct, so that's something is happening with it. So you people can write the points and then we'll go ahead. And tropo word का मतलब ना turning होता है. ठीक है, tropo word, why am I saying this? Because there is like a lot of questions which is you know there are a lot of books, question books in which it is asked that what is the meaning of tropo. So tropo means turning, and turning into a good weather or bad weather depends upon this matter. All right. All right. Shall we go ahead?
No.
And the temperature is decreasing at a rate of 2 degrees Celsius per 1,000 feet. But Jesse, tropopause, the moment tropopause is reached, you know, from the surface of the earth, we started the temperature decrease at a rate of 2 degrees Celsius per 1,000 feet. Now, when the tropopause has reached, the temperature will stop to fall. It will stop. Neither it will increase, neither it will decrease, but whatever the temperature was, you know, what it was actually encountered at the tropopause. तो वो अब जैसे जैसे आप ऊपर जाओगे, the temperature will be the same which was actually mentioned, which was actually observed at the tropopause. अब वही रहेगा कुछ टाइम तक. Done, guys? Done, Sakshi. Okay. So before we come on to the ऊपर वाला topic, I would like to explain कि अब बातें करी ना, we talked about कि भाई the tropopause is actually at a lower altitude as the latitude is increasing. The temperature it depends upon the temperature on that particular day, time of the day, है ना. और what all did we talk about? और क्या बात करी हमने कि season of the year, correct? इतनी बातें करनी क्यों है? सबसे पहला मेरा सवाल यही आता है. Why do we want to know that what is the height of tropopause? Why this is such a big concern? The concern is because the maximum height of a cloud top, क्या होता है cloud top यार? This will be there wherever the tropopause is. क्योंकि उसके ऊपर तो क्लाउड ही नहीं बन रहे ना. स्ट्रेटोस्फीयर में कहाँ क्लाउड बन रहे हैं? नहीं बन रहे हैं. एक हैं थोड़े से वो बन रहे हैं, मतलब एक ही टाइप है जो बन रहे हैं, which we'll talk about. ठीक है. So but most of all your clouds are actually forming at the top, or the cloud top will be what do you say, found at the wherever the height of the tropopause is. The height of the tropopause is 11 kilometer. 11 kilometer पे you will find the top of the cloud, the head of the cloud basically. ठीक है. एक तो ये थी. Second, presence of jet stream. Jet streams in simple terms are high speed winds. Like 60 knots तो base है. 60, 100, 120. The ones who have actually traveled in metro, especially Delhi metro, and especially been in Rajiv Chowk metro station, आपको अंदर घुसने की जरूरत नहीं है भैया. आप बस खड़े हो जाओ प्लेटफॉर्म पे, लोग खुद आपको धक्के मार के अंदर ले जाएंगे और खुद ही आपको धक्के मार के बाहर भी निकाल देंगे. Even if you don't want to say get out in Rajiv Chowk metro station. यही सी है, सीन यही है. जिसने नहीं एक्सपीरियंस किया है, जो दूसरी जगहों से आए हैं, प्लीज करो एक्सपीरियंस, तब समझ आएगी मैं क्या बात करना चाह रही हूँ. So for example, this is beautiful winter times, and we have a type of jet stream which is called as subtropical jet stream. और ये इसी महीने में दिसंबर, जनवरी, फरवरी में ही चलती है वेस्टर्ली डायरेक्शन में. लाइक वेस्ट से आ रही है, ईस्टर्ली डायरेक्शन में जा रही है. ठीक है. तो दिल्ली से अगर मैं कोलकाता जाना चाहती हूँ, बेस्ट है अंदर घुस जाओ. जिस भी ऑल्टीट्यूड में ये एसटीजे ये वाली जेट स्ट्रीम मिल रही है ना, इसके अंदर घुस जाओ. फ्यूल कम खर्च करोगे, ये खुद ही धक्का मार के तुम्हें कोलकाता पहुंचा दी. बढ़िया है भाई, मेरे को चाहिए ये. स्पेशली ओनली इन दिस मंथ ऑफ कोर्स, एंड नॉट फ्रॉम कोलकाता टू दिल्ली, क्योंकि मुझे उसमें फिर ज्यादा फ्यूल फूकना पड़ेगा, है ना. बट दिल्ली टू कोलकाता आई वुड लव टू डू इट. ये नहीं खर्चा. अब मान लो 110 नॉट्स की अगर चल रही है, फिर 110 नॉट्स की स्पीड से मेरे को धक्का देके और जो भी मैं पावर से व्हाटएवर माय एक्चुअल स्पीड इज, उसमें वो वाली स्पीड ऐड ऑन कर दो यार, जल्दी पहुंचा देगी. कुछ नहीं करना है भाई, तेल कम फूक रहे हैं, इससे ज्यादा क्या चाहिए. बेस्ट. So that is why it's important that we know where is the tropopause का height. What is the tropopause का height? क्योंकि that way you will jet stream, और मेरे को नहीं ज्यादा खर्चा करना, खुद ही ले जाएगी. Next is turbulence, clear air. Why do we call it as clear air turbulence? क्योंकि यार आपको दिख नहीं रही है कि यहाँ turbulence है. जब लोग अंदर घुस जाते हैं turbulence के बाद, तब पता चलता है, क्योंकि it's clear air. And what is a turbulence? It is this is a disturbed airflow which will वही अपने aircraft को झूम बराबर झूम. ठीक है. We'll talk what is that. Then we'll be talking about turbulence more. Maximum wind speed is actually also found around the tropopause. Maximum jet stream. ठीक है. दोनों बातें same ही है वैसे. So that is why it's important that we know, what is the height of tropopause. Got it? So पहले आप लोग ये point लिखो, फिर I'll explain this upper point. I need the board for it. यस, और इंडिया के ऊपर से एक ईस्टर्ली जेट स्ट्रीम भी पास होती है, जिसको हम इंडियन है ना, तेज पर ज्यादा तेज नहीं है. ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम. इट इज द ओनली जेट स्ट्रीम विच इज गोइंग इन ईस्टर्ली डायरेक्शन. मतलब वो है ना कि कॉन्फिडेंस देखो उसका. बाकी सब जेट स्ट्रीम्स आर एक्चुअली फ्लोइंग इन द डायरेक्शन विच द अर्थ इज रोटेटिंग, है ना, वेस्टर्ली मतलब ईस्ट टू वेस्ट ऐसे तो फ्लाई कर रहे हैं, मतलब यू नो रोटेट हो रही है अपनी अर्थ। तो वेस्टर्ली जेट स्ट्रीम जितनी भी होती हैं, वी विल टॉक अबाउट इट, तो वो सब वेस्टर्ली डायरेक्शंस में जा रही हैं। सिर्फ ये एक लौती जेट स्ट्रीम है जो सिर्फ और सिर्फ नदर्न हेमिस्फीयर पे मिल रही है और ऑपोजिट डायरेक्शन में फ्लाई कर रही है। यार देखो क्या कॉन्फिडेंस है उसका, ऑपोजिट डायरेक्शन में वो मूव कर रही है, दैट इज फ्रॉम व्हाट यू से फ्रॉम वेस्ट टू ईस्ट, ईस्टर्ली साइड पे, ठीक है। और कंपेरेटिव टू द अदर, compared to other jet streams, it's actually what do you say, थोड़ी मतलब comparatively to the other jet streams it's actually weaker, speed इसकी कम है। क्यों? यार opposite direction में fly कर रही है ना, अर्थ जा रही है फ्रॉम ईस्ट टू वेस्ट और ये जा रही है ऑपोजिट डायरेक्शन में वेस्ट टू ईस्ट, इसके वजह से इट इज एक्चुअली कंपैरेटिवली वीकर। एंड ये कहाँ पे मिलेगी? यू विल फाइंड इट यू नो व्हाट यू से अराउंड 13 डिग्री नॉर्थ, मतलब तमिलनाडु के पास, तमिलनाडु पे यू विल गेट ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम्स, ठीक है। Okay. Okay. So shall we go ahead? Okay. So yes. All right. हो गया? ऊपर वाला नहीं लिखना है, मैं बताऊंगी जब लिखना है। आई वॉन्ट टू एक्सप्लेन सम पॉइंट। नाउ equator, ठीक है, approximately over here assume India. Please don't make fun of my India, मैं इससे ज़्यादा नहीं बनाती। I'm not a geography teacher. Okay. Next is your the pole, 90 degree north, 0 degree. Okay. So at ये है the troposphere. This is the troposphere and this blue line is the tropopause. Okay. At 90 degree north and south, what is the height? 8 to 10 kilometers. Okay. At equator, it is approximately 16 to 18 kilometers लिखा हुआ है, 18 kilometers. And over India, it is approximately 16.5 kilometers. And अगर मैं इसको मानूं, assume करूं this portion as 45 degree north, over here it is approximately 11 kilometers. ठीक है। अब एक बहुत इंपॉर्टेंट बात है साक्षी, है ना, लेट्स अगर मैं यहां से एक और चीज मैं क्लियर कर देती हूँ, पर एवरी किलोमीटर द टेम्परेचर ड्रॉप इज 6.5 डिग्री सेल्सियस। हमने बात किया था फॉर एवरी 1000 feet द टेम्परेचर ड्रॉप इज 2 डिग्री सेल्सियस, एंड फॉर एवरी 1000 feet अगेन वी ऑल्सो से द टेम्परेचर ड्रॉप इज 3 डिग्री फ़ारेनहाइट, 3 डिग्री फ़ारेनहाइट। और नॉर्मली ये फ़ारेनहाइट वाला नहीं पूछते हैं, बट जस्ट फॉर नॉलेज। ओके, सो किससे बात कर रही थी मैं? साक्षी से। साक्षी, टेम्परेचर यहाँ से ड्रॉप होना शुरू हुआ होगा, है ना, फ्रॉम द सर्फेस द टेम्परेचर एट द पोल वुड हैव स्टार्टेड टू ड्रॉप। ओके, अगर मैं अज्यूम करूं कि यहाँ पर अप्रोक्सीमेटली कितना टेम्परेचर हुआ, -50 है ना, -50 डिग्री सेल्सियस। और इक्वेटर के आसपास तक अगर मैं ट्रोपोपॉज तक पहुंचूंगी, हाउ मच टेम्परेचर वुड हैव ड्रॉप्ड? More than the tropopause polar tropopause or less than the polar tropopause? The equatorial tropopause का temperature will be less than the polar tropopause का temperature, or the or more than the polar tropopause का temperature? Will be more or less. Can anyone tell me why the temperature has dropped approximately to -80 degrees Celsius? The temperature was able to only drop till -50 degrees Celsius at the poles.
Because the altitude is more deeper.
Exactly, because the height is approximately double over here. Here 8 का double होता है 16 kilometers. 8 kilometers का double है 16 kilometers. So 16 kilometer तक, approximately 18 kilometer तक temperature is dropping. So of course बहुत ज़्यादा कम होगा ना. Correct? Got my point? And ये वाला please लिख लेना, average height of tropopause. And this is the equatorial tropopause. And this is your polar tropopause. Okay. Oh, in there, just for you to remember. 16. Okay. So guys, you can write all these points also. Okay. हाँ जी, और बताइए. Anyone who have any doubts? गाइस कंजूसी मत करना, थोड़ा बड़ा बड़ा अच्छा अच्छा बनाना. प्रतीक तुम तो बिल्कुल मत करना. All right, so let's go ahead. Okay, so now you guys can write these points down. Just a minute. Okay. So temperature at the tropopause over the equator is less than the poles because equatorial tropopause height is nearly twice the height of the polar tropopause. So over the equator is less. That means यहाँ पे एक यार वो कर लो ना इसको mention ही कर लो. So approximately is less. Bracket में put it as minus 80 degrees Celsius. And pole because equatorial pose यहाँ पे it's approximately minus 50 degrees Celsius. All right, so let's go ahead. Then comes your stratosphere, the next layer. That was all about the words and talks related to your. Okay, so this is my Earth. ठीक है, Earth से approximately 11 kilometers तक average 11 kilometer तक is your troposphere. फिर आपकी stratosphere तो है actually from 11 to 50 kilometers, ठीक है, but 11 to 20 kilometer थोड़ी सी important है. क्यों? क्योंकि 11 to 20 kilometer तक isothermal layer है. We have isothermal. Okay, so isothermal layer. Now isothermal layer is the layer in which Ronak क्या होता है? नहीं भाई वो तो नीचे भी फ्लाई कर रहा है. But I'm asking that what is an isothermal layer? अभी लिखा था temperature tends to stay constant. ठीक है, it ceases to fall. Now this is from 11 to 20 kilometers. But ये 11 to 20 kilometer is also a part of which layer? Tropopause, troposphere or stratosphere? It is a stratosphere. मैंने ये क्यों 11 to 20 kilometer लिखा? Because I want to show that this layer is actually your inversion layer. Sorry, isothermal layer. Isothermal layer. वैसे पूरी stratosphere is from actually approximately 11 to 50 kilometers, but 11 से 20 kilometer it is a isothermal layer, and above 20 to 50 kilometer it is a inversion layer. तो स्ट्रेटोस्फीयर में ही इन्वर्जन लेयर भी है और आइसोथर्मल लेयर भी है, दोनों है, ठीक है। ज्यादा खास नहीं है यार इसके बारे में बताने में। इस वाली लेयर में एक बात ये जो एक पॉइंट तो ये कि यार 11 to 20 किलोमीटर it is a isothermal layer which is present in the stratosphere layer, and from 20 to 50 kilometer it is inversion layer, ठीक है। एक और the second point fact about stratosphere is that कि 20 to 25 किलोमीटर है ना, वहां पे the ozone layer का concentration is highest. फर्स्ट वाज कि भाई इसमें इन्वर्जन भी है, आइसोथर्मल लेयर भी है, दोनों है। सेकंड इज दैट कि द कंसंट्रेशन ऑफ द व्हाट डू यू से द कंसंट्रेशन ऑफ ओजोन लेयर इज मैक्सिमम एट 20 to 25 kilometers. Second point. Third point is that because it doesn't have that much of it doesn't have any moisture content and that much of what do you say density of air molecules, तो कैसे बनेगा वेदर? वेदर ही नहीं बनेगा। मोस्टली नो वेदर क्रिएशन, एंड नो वेदर का मतलब स्टेबल लेयर। वेदर क्रिएशन मतलब अनस्टेबल, इनस्टेबल लेयर, एंड अगर वेदर क्रिएशन नहीं हो रहा है दैट इज कॉल्ड एज अ स्टेबल लेयर। कुछ नहीं है भैया, जबकि स्टेबल लेयर है, इट इज अ स्टेबल लेयर, फिर भी कुछ अमाउंट के एक टाइप के क्लाउड्स बनते हैं which are called as nacreous clouds or mother of pearl clouds, the name of it. देखने का मन है, आते रहिए आगे क्लास में, गोल्डन एप्लेट्स एविएशन पे लाइव आते रहिए। वी विल टॉक अबाउट क्लाउड्स, और उस दिन उस चैप्टर में आई विल शो यू nacreous clouds also called as mother of pearl clouds, ठीक है, सही है, परफेक्ट। चलो, तो now let's talk about it. Stratosphere extends from Tropopause, और Tropopause की हाइट क्या है नॉर्मल एवरेज वाली? 11 to 50 kilometers. So 11 to 50 kilometers. The temperature remains steady up to 20. भाई इस लाइन का मतलब ही ये है कि it is a isothermal layer. Isothermal layer. And thereafter increases with height. और इस लाइन का मतलब है it is a inversion layer. तो basically isothermal and inversion layer both are present in stratosphere, और troposphere में तो सिर्फ normal layer है, normal layer है. So the upper boundary of the stratosphere is called stratopause, where the temperature is of order of 0 degree Celsius. यार अब क्या हुआ, 11 किलोमीटर पे सपोज -56.5 टेम्परेचर सीज हो गया, 20 किलोमीटर तक इट रिमेन्ड सेम. Now after 20 kilometer till 50 kilometer, temperature started to increase. So -56.5 degrees Celsius will now become -54.5, -50 डिग्री सेल्सियस. ऐसे करते 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 जब तक 50 किलोमीटर पहुंचता है वहां पे टेम्परेचर 0 डिग्री सेल्सियस हो जाता है. तो इसीलिए दे हैव मेंशन्ड अपर व्हाट डू यू से अपर बाउंड्री ऑफ द स्ट्रेटोस्फीयर, दैट इज कॉल्ड एज स्ट्रेटोपॉज, वेयर द टेम्परेचर इज ऑफ द ऑर्डर ऑफ 0 डिग्री सेल्सियस. वो ड्रॉप, वो इंक्रीज होते 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 -56.5 डिग्री सेल्सियस आप टेम्परेचर इंक्रीज करो तो 0 डिग्री सेल्सियस आएगा ना. और कहाँ आएगा 0 डिग्री सेल्सियस? At a higher boundary of the at the boundary of the upper boundary of the stratosphere, that is stratopause. Got it? Lower boundary of the stratosphere क्या है? Tropopause. और upper boundary of stratosphere is stratopause. So there is a 5 kilometers above which it absorbs ultraviolet radiation of sun and causes the increase of temperature in this layer. क्योंकि यार वो बात ये है कि what do you say, जो आपका O3 molecules जब ब्रेक होते हैं, O2 molecules जब ब्रेक होते हैं into O3 molecules, that is a exothermic reaction. Exothermic reaction, and this is the reason why the temperature starts to increase with increase in altitude. ठीक है? Okay, stratosphere is a stable region with low humidity, so no weather. is occurring over there. वेदर अकर होने के लिए यार वैसे वाले क्लाउड्स बनने चाहिए ना जो बारिश करें या ओले बरसाएं. हेल्स, हेल कभी साक्षी हेल देखे ओले पिटे हो कभी ओले से? बहुत भयंकर नील पड़ता है भाई. जिसने नहीं खाई है, you are leaving some very what do you say a very important part of your life. उसने ओले से नहीं मार खाई, उसने फिर क्या ही खाया. ठीक है. However, very rare type of clouds are found called nacreous. ओले देखने हैं उसके लिए भी प्लीज क्लाउड वाली चैप्टर में क्लास आना है. Nacreous clouds, mother of pearl, occur between 20 to 30 kilometers, that too only in winters. ठीक है. You people can write the points. Okay, shall we go ahead, guys? ठीक है, I get it. All right. So that was all about stratosphere, and now let's go on to let's go on to mesosphere. बहुत कुछ खास नहीं है इसके बारे में बात करने के लिए related to mesosphere. It extends from 50 to 85 kilometer. Now the temperature has again started to decrease with height. Temperature अब फिर से decrease हो रहा है. 0 डिग्री सेल्सियस आ गया, अब वापस से -2, -4, -6 ऐसे temperature started to. वैसे normally it is approximately the lapse rate over here is approximately 1 degree Celsius something. ज्यादा बहुत ज्यादा वापस से 2 डिग्री सेल्सियस के हिसाब से it's not dropping, it's dropping at a lower rate, at a lower lapse rate. Noctilucent clouds are present in this layer. फिर से इन clouds को जानने के लिए क्लास आती रही, ठीक है? Cloud chapter. All right. So now let's go on to okay. Yes, please. Right. बस यही है कि mesosphere में noctilucent, mesosphere में noctilucent और mesosphere में noctilucent और stratosphere में nacreous clouds. Only these two things. Okay. Done, guys? Sakshi? Troposphere above 85 kilometers, temperature now again starts to increase because of ultraviolet radiation. ठीक है, क्योंकि अब वो outer space वाले region में आ चुके हैं. So because of which the temperature has started to increase, and in this layer the temperature increases above 85 kilometers. You will get thermosphere. Write this also. We'll go ahead. हो गया?
तो ये भी वर्जन ले रही है,
बोल सकता है, हाँ, you can say it. Okay, this image is my favorite image. I'll tell you why. क्योंकि ये पूरा जो हमने एटमॉस्फेयर का चैप्टर किया है वो इसी में सीमित है. शुरुआत करेंगे. I love this image. It makes everything so clear, so beautiful. मतलब इकलौते, you know what do you say, चैप्टर से मैं पूरा का पूरा, मतलब इस पर्टिकुलर एक इमेज से मैं पूरा का पूरा चैप्टर समझा दूँ, और बहुत ही ब्यूटीफुली. ठीक है, तो शुरू कर रहे हैं. अर्थ, ओके, 0 से 11 किलोमीटर इज द हाइट ऑफ ट्रोपोस्फियर. और ट्रोपोपॉज आपको ये जो ब्लैक वाली लाइन है, दिस इज योर tropopause, okay, where the temperature is ceasing to fall. Okay, temperature is actually decreasing with increase in altitude at a rate of -2 degrees Celsius per 1,000 feet in this layer. This layer is troposphere. This layer is commonly called as unstable layer, and the lapse rate or the temperature drop is approximately -2 degrees Celsius per 1,000 feet, -3 degrees Fahrenheit per 1,000 feet, and -6.5 degrees Celsius per kilometer. This is written wrong over here. Just a minute. Per kilometer. All right. Okay. What else? Let's see. Then ये जो green वाली line है ना, this green line, this is actually I'm showing the isothermal layer. So from 11 to 20 kilometer, it is the isothermal layer. Okay. Just a minute. Isothermal. 11 to 20 kilometers. Okay. Then this blue zigzag line, इधर मैंने लिखा हुआ है वैसे, isothermal layer 11 to 20 kilometers. Then you have this blue zigzag line. This is actually your ozone का concentration of approximately 20 to 25 kilometers. And from this, what do you say? From 11 to 20 kilometers isothermal. From 20 to 50 kilometers it is your inversion layer. Yeah. This is your inversion layer. That is from 20 to 50 kilometers. Okay. Stable layer है. Nacreous type of nacreous clouds करके clouds बनते हैं in this layer. इसमें तो सभी बन रहे हैं यार. जो भी हम देखते हैं वो सबके सब ये इस वाली layer में troposphere में. Then above troposphere, temperature starts to drop again between 50 to 80 kilometers, and this is your mesosphere. Which has noctilucent clouds. इस इमेज में मैंने दो चीजें और एक्स्ट्रा डाली. That is that sun का जो radiation होता है ना, solar radiation, that is called as short wave radiations. The one which is actually coming onto our earth. यार किस किस के दिमाग में ये चीज है कि atmosphere जो है, the atmosphere, I'm not talking about ground, I'm talking about atmosphere. The air surrounding us, that atmosphere में atmosphere का जो temperature है, the increase of temperature of the atmosphere is because of the sun. Who all thinks that this fact, this is a correct fact or a wrong fact? The atmosphere gets heated up because of the sun. How many of you think this? Anyone? तो किससे हो रही है फिर? Earth से. It is actually getting heated up because of the earth. So this solar radiation of the sun is by the sun is actually being absorbed by the surface of the earth. The earth absorbs it, and then it releases out this heat as long wave radiation. As long wave radiation. Now this earth got heated up. It released this heat into the atmosphere. So now atmosphere got heated. ठीक है. अब यार इसने जब वो पूरी की पूरी heat release कर दी, so now this has actually the atmosphere, the surface of the earth has become cool. Surface of the earth will it lost all the heat. It lost all the heat. So when the heat which has been lost by the surface of the earth is now in the atmosphere. So automatically the surface of the earth will cool. And this process mostly is high during the night. और रात को nocturnal कहते हैं. And hence this whole scenario is termed as nocturnal cooling. And this long wave radiation which is being emitted by the surface of the earth is called as terrestrial radiation. ये solar radiation है which is being absorbed by the earth, और ये जो heat wave है which is being released by the earth is termed as terrestrial radiation. Got my point? So you people can draw the sun and all the other points. यार ये image is amazing, especially when you are revising atmosphere chapter. All the points are actually covered up in this. ठीक है, चलो. Okay. Okay. So what is nocturnal cooling? Again, I'll just explain. When the earth is getting heated up, it is getting heated up because of the sun, solar radiation. Ab solar radiation was absorbed by the surface of the earth. Now the same heat is being actually released by the earth after a certain point. So when the earth is releasing this heat, it's mostly during the night. और जब atmosphere में अब वो चले गया, the whole heat, the surface of the earth will get cooled down. And this heat which released was called as terrestrial radiation, as solar radiation, which is long wave radiation. This one is long wave. Terrestrial radiation is long wave, and this solar radiation is short wave. And this heating, this cooling which has happened of the earth takes place during the night, and this is called as nocturnal cooling. Earth surface नहीं, that is different. That is the temperature drop at a higher. जैसे से ऊपर जा रहे temperature drop हो रहा है. That is because of that की altitude ऊपर the temperature at a higher altitude is less. But ये Earth क्यों ठंडी हुई? Earth कैसे ठंडी हुई? हाँ, ठीक है. All right. So I hope everyone has drawn this. Done, guys? So that, where is it? Corona मत देखो ये.
पुराना ही मतलब बना हुआ है।
All right. All right. So that's it for today. And we'll continue from here tomorrow. Bye bye, guys.